can't beat the in-person interactions, the lunches, the dinners. The quality of the people that you meet over coffee here is just phenomenal.
Hey everybody, welcome to CppCon. To those online, thanks for tuning in. I'm Brian Ruth, and today we're going to be talking about the preprocessor, everything you need to know and more. So when you first start writing C++, one of the first things you have to do is include a header. So you never really stop to think, what is actually happening when you do this? So here we've got the header that you're including, and we've got your main function, and it's going to call some functions and stuff like that. But when the preprocessor starts handling it, what it's really doing is it replaces that include with all of the text that was actually in your include. So every time you do more and more includes, all of this text just keeps getting pasted on top of the code that you're using. And this individual unit is called a translation unit. And it is part of the translation phases. So as you go through your code, the first 3 phases are dealing with manipulating character representation and things like that. Phase 4 is your preprocessor. Phase 5, you're doing a little bit more character stuff. String literals. Then finally at phase 8, phase 7, you're doing compilation. And then you're doing linking, and then we all make money selling products. But for the purposes of this talk, we're going to focus on the preprocessing portion only. And about this talk, this is not advocating for or against the preprocessor. This is not about saying different ways that you should go about using it. This is basically about, this is what the preprocessor does. This is the way that it's done in C. This is the way that it's done in C++. And here are some alternatives in certain situations that you can use. Because as we'll find out throughout this, there are still uses for the preprocessor. All right, first, the preprocessor. It is essentially a text replacement mechanism. It's going to go through your code, and these directives are going to be expanded, and it's going to replace the code in the source code you write. So when you're looking at a preprocessor directive, a macro or something like that in there, the code you see in your editor is not the code that the compiler will actually see when it starts to compile your code. So that allows us to do some pretty interesting things with manipulating code, generating code, and depending on what you're doing, you may even be able to manipulate how your compiler compiles the code and how your linker links the code. So C++ did inherit the preprocessor from C, so a lot of the stuff applies to both languages. But since then, they have kind of diverged and gone in different directions, and they've borrowed from each other throughout time. So we'll take a look at where those things differ. And although its death has been predicted for many, many years, it's still here. It's still the most portable way to write generated code. It's used extensively in C and C++, C++ interoperability, and it's a good idea, even if you're not going to be using it, to know what it is when you start encountering this code. So a good thing, like a good mental model to keep in mind when you're dealing with the preprocessor is that all of this is happening before the compiler gets involved. So things that your compiler can do and reason about with your code, the preprocessor doesn't necessarily have access to that information. So preprocessors are introduced by the preprocessor directive. So the #, octothorpe, hashtag, whatever you want to call it, is going to introduce some directive in the code. Now, this could be followed by any number of spaces. It can have leading spaces. Any of that's fine. If you just have a # by itself and hit, it's essentially a no-op. But if you want to use a macro or the preprocessor directive, the # has to be the first non-white space character. We'll get into directives later, and the stuff is going to kind of depend on what directive you're doing. But one thing that you cannot do in the stuff portion is introduce a new directive. So you can't have another # and then something else as part of a macro. So what is a directive? The directives are broken into these different categories. We're going to go over them individually. This is as far as I can tell, a pretty complete list of all of the current directives that are available. Include, conditional, replace, error, compiler extensions, and file and line information. There is also modules. So in C++23, there is the ability to import the string header and stuff like that. But that's a completely separate talk. We're not going to get into modules too much in this because we're going to be focusing mostly on the legacy preprocessor stuff. Okay, so back to our including a file. What does that actually do? So if you have an include a file, you do the pound include, the file to include, and that is actually going to be evaluated by the preprocessor. So you can actually have a macro expansion as part of your include directive. So post-expansion, it needs to kind of go into two different ways. So your angle bracket version, that's going to be a relative path from your system folder is where it's going to first start looking. So that's why you see a lot of times the system string is going to be included with the angle brackets. So the first place it's going to look it up is going to be your system include headers. If it's not found there, it doesn't necessarily have to, but I haven't found a compiler that doesn't. Fall back on looking in other locations. Same thing with the quoted version. So the quoted version is what we generally use for look in this directory or relative to this file's directory first, then look at possible other include directives that you passed into the compiler, and then failing that, fall back onto the system lookup folders. And if that specified file is not found, then it's just going to fail to compile. So include, when to use, when you don't have module support, which right now is a lot. And the C alternative, none, is the only way to do it. And C++20 modules. And then in C++23, like I said, you'll be able to include standard headers. Kind of an aside real quick. If you want to actually see what your preprocessor is doing, so here's how to view the preprocessor output on a couple of the major compilers out there. And you can examine that .i file. If you go to Compiler Explorer and you pass that in, it'll spit out all of the generated code out on the side there. So if you want to take a look at what your crazy macros are doing, this is a good way to do that. All right. So first we're going to start out with object-like macros. You'll see this a lot in C code to replace constants and things like that. So here we've got a pound-defined pi for a value, a radius for a value, and then we've got this circumference, which is going to put those things two together. Now with macros, you actually it's part of the preprocessor. So you have to have preprocessor definitions in order to do math and things like this. In C, it's called a constant expression in C requires stuff like this. So here we've got the int main, it's going to return the circumference, and conceptually what's happening is that first the circumference, oh, I changed my slides. So an object like macro, it's going to start out with your define. It's going to introduce an identifier to the preprocessor. So this is what tells the preprocessor, hey, this has this meaning. So when you find this, replace it with this text. So the identifier, it's going to have to be a valid name according to naming guidelines. And it must be unique to this translation unit, and we'll get to that in a little bit. The replacement, again, cannot introduce a new directive, but pretty much anything is allowed, but there's no guarantee that it's actually going to compile. And then there is a kind of an inverse of the define, which is undef, which basically tells the preprocessor, from this point on, this identifier is no longer anything, so don't replace the text. Now we're going to get into this. So conceptually what happens is your circumference is going to be expanded into the pi times radius. So it's going to replace circumference with whatever you had there. And then it's going to replace those, it's going to expand those macros out and replace them with the actual values that you had defined up there. So the code that your compiler is actually going to end up seeing is going to be this code here, not the code that we saw with the circumference. Which leads to some very interesting debugging if you're trying to navigate macro trees and try and figure out, well, where is this value getting changed? This is a long list of reserved preprocessor identifiers. So even though you can name anything valid, C or C++ variables, there are some reserved names that you should avoid. You can take a look at that link, but the TLDR on that is don't start with a single underscore, don't have it contain a double underscore. Don't, unless you're being really masochistic, don't try and pound define out a language keyword. I have seen the pound define public or private public before, It's not fun. And don't have it match a standardized name, so like _file, memcopy, vector. So object-like macros, when to use them? When you need to use a value during the pre-processing phase. Again, variables and things that your compiler knows are not available then. When you need to support multiple compiler capabilities. So if you have to make some code that compiles for 2 different versions of a compiler, one may support concat_expr, one may not. So that type of thing. And then command line flags, if you want to pass in flags on the command line that can adjust how your code changes. In C, if you need to use a constant expression, in a lot of older code, you'll see like a #define array size, 44. Use an enumeration. Enumerations are easier to work with, and you don't have to kind of go through all the macro levels. So if you see an unnamed enum used like this in C code, really all that is defining a static const int to be able to use in a constant expression. And then for C++, use concat_expr or static const values. You can assign to const values in C++ with previously constant values, so you don't have to worry about that. So allowing command line flags. So basically this is just going to say, hey, if we're doing a debug build, we can specify that on the command line, and we can use if const_expr to just get rid of that print statement from the command line. So, in addition to being used in the code, this can actually also you can use these flags in your build system to determine which files to even include in a compilation. So directives do not have scope. The file is processed from top down, so moving a directive can change code. So I've seen people write code where they define a value in a function, assuming that it's scoped to that function, but it's not. So here we define myval as 7 up at the top there. The main function is further down, and you see every time the main function is called, it's going to be 7. And then further down in that other function, we redefine it to 9. Now you may, if you have your warnings turned on and actually listen to your warnings, get a warning on this. But if under maintenance, somebody just decides to reorder the way the code is in the file, all of a sudden that changes the value that's printed out in main. So be very, very careful. This is another good reason to use those local enums, is they do have scope. Conditionals. So you might have seen a lot of code like this. This is a very long slide, so I'm going to sit back here and read from it. So conditionals, they're going to be an if, an else if, else. The expression can be optionally surrounded by parentheses. Now there's some things you can use next to that expression, some little directives there. So defined is one of them that you can use. That can be with or without parentheses. There's also in C++ 17 has include, which allows you to check for a file's existence. And in C++ 20, there's has C++ attribute, and this is where you can figure out whether or not the compiler that you're using actually supports a particular feature or not. And something to keep in mind that is a source of a lot of interesting bugs is that the result of this constant expression is actually numeric, not Boolean. So that means that a value of 0 is false, and a value of not 0, so either negative or positive, is true. So there have been many subtle bugs where there's a value in there, and you don't know whether or not you put it to false, you put it true, you put it some value, and it may or may not evaluate the way you think it is. Furthermore, if a identifier is not available to the preprocessor, most of the time it just defaults it to 0. So again, even if you don't have something defined, the preprocessor will see, oh, I don't know what this identifier is, it's false. So that's another tricky place to have a bug. So elif is just like an else with an if. That has to be after an if. Else, again, optional, but you only have one of those per if. And then there's some shorthand for the if defined and if not defined that you can use. And in C++ 23, they're proposing the elifdef and elifndef. Again, just to kind of shorten things up. But these are essentially equivalent shorthands for saying like if defined or if not defined equals 0. And one catch too with ifdef and ifndef, you cannot use parentheses around value because the parentheses are actually implied. If you put parentheses in there, it complains. So I'm going to kind of go through how a conditional is evaluated, how the The preprocessor conceptually is going to go through and start substituting things in there, so bear with me. So we got this. The first thing it's going to do is it's going to go and it's going to say, all right, include our pub config. So it's going to paste that stuff up at the top, bring in the things from pub config. And then the next thing it's going to do is it's going to say, all right, well, I need to check to see if the pub supported is true. And pub supported is defined, and its value is 1. So it's going to say if 1 and 1, include pub.h. Okay? So now that stuff's gone. We don't have to worry about the if 1 and 1 or the else anymore. And now we're going to go and include pub.h. And we're going to paste all that stuff in there. And now we've got the if and def pub.h, define pub.h, and then include pub config and some other stuff. All right? So now we can get rid of that include gird around the pub.h. And the next thing we're going to do is include pub config. Okay, pub config actually now has an if and def config. Well, we already included the config earlier in there, so that macro is already defined. So all of the stuff between the if and end if, we can actually now get rid of. All right, so the next thing is the asset support down there on the bottom. All right, so asset support is going to be defined. Whoop, I want to go forwards, not backwards. So asset support is going to be defined. We can get rid of all the other stuff because we don't care about it anymore. And substitute that out. It's going to be 1. And this is, of all that code, the final code that we get, that actually gets passed on to our compiler. So for conditionals, they are most often used in include guards. They can also be used for C linkage specification if you need to go back and forth and make sure that the names aren't mangled when you're linking something with C, so that if def C++, extern C, you see a lot. You want to use very sparingly to exclude code. So if you need to reduce your binary size or certain things don't apply in certain situations, you can use that to exclude things. But you want to use it very sparingly because the more you intersperse that throughout your code, the more difficult it is to read and follow and maintain. And you can use it to check for header and feature availability, which I'll show in a second. So for C, you want to attempt to restructure your code to limit inline execution. So move things into a separate function, split headers based on whether you want to include things or not. Try and limit the amount of stuff just to make the code easier to work with. And then for C++, you can use const.expr when all the code is available, and then module imports as well. You can use those to bring things in conditionally. So what about if const.expr? So if I have this section of code here and I've got a const expression boolean, bark used is true. If bark used, I want to define this function. I also want to use an activity. So I'm basically determining whether I want to process barks or process activities. And I use an if const.expr down there to exclude the path that I'm not going to use. But all paths need to compile. So bark used right there is not a preprocessor identifier. So because it's not identified, the preprocessor treats it as 0 because nothing is named bark used as far as the preprocessor is concerned. And, well, you can't use a preprocessor or a const.expr if outside of a function, so there's no way to really exclude this code. And both paths of the const.expr if have to compile. So because that is, if bark used is true and bark activity isn't in there, one of those two paths is not going to compile. It's not defined at all. So even if the path isn't taken, the const.expr if needs to be valid code. So if const.expr is not a substitute of if. There's a lot of similarities between the two, but the conditionals in the preprocessor have different semantics than const.expr if. So this would be the appropriate way to go out and exclude this code conditionally. All right, checking files for attributes. So this is an example of using the has include. So here we want to check to see if the header exists, include the header. Otherwise, we're going to just stub it out so that our code will compile and not really do anything. And here we want to make sure, all right, does our compiler support const.expr? Well, if our compiler supports const.expr, we're just going to say replace it with const.expr. Otherwise, just don't do anything. And then that allows us to write code like this in the actual function. So we use the all caps const.expr, and when it comes back in and it changes things, it's going to replace it with the appropriate either const.expr or not. You could also have changed that to const. Now that I look at it, I probably would have done that. But then it'll call that function, and it'll either call the real function or it'll call the stub.1 you put up top. Some code exclusion anti-patterns that make things difficult to maintain and make things break in very subtle ways. So conditionally removing something from a struct. This is going to basically make it so that if somebody serializes some code in one mode and then someone turns on a flag, then all of a sudden all the integer values that were serialized are going to break. So it's a good idea just to keep those things in there. You're not really saving too much by conditionally putting those things out anyway. Changing flow control. This is just something that makes it really difficult to maintain code and reason about when certain branches are taken and what things in particular are even considered by the compiler. And then excluding members in a struct. Again, this is something kind of with the serialization issue or manipulating things over the place. This leads to a lot of if-defs, like conditionally inside of code. If you do need to kind of conditionally remove things to reduce binary size or reduce RAM size, make multiple different structs and just use the appropriate one that you're looking for. All right, function-like macros. All right, function-like macros. You're going to have an identifier, again, same as usual. When used elsewhere, so if you make a function-like macro, it requires the parentheses to be used because it's treating it kind of like a function replacement. And there could be no spaces between the identifier and the parens. Comma separated list of arguments. Number of arguments is implementation defined. So there is, based on the way the preprocessor works, a certain number that it will allow. Whatever is put in args is passed in the code. Always surround parentheses with args. I'll show that in a second. And we'll also show the if referenced more than once. If you do need to have a multi-line macro, just end the line in a backslash, and then you can continue that macro to multiple lines. And then the replacement code. Pretty much anything goes. But the last line of a function-like macro generally does not end in a semicolon, because you want to treat it kind of like a function in your code, so that it makes sense to have the semicolon where the function is called, not necessarily in the macro itself. So let's take a look at this, this function-like macro. So max_val, very, very common function-like macro that you see. Problem with that is that it has side effects. So if you pass in a --F2 there, it's actually going to paste in that --F2 twice, and it's going to evaluate that twice. So again, be careful when you're doing stuff like this. You also want to make sure that you surround all of the individual arguments, because again, these aren't arguments, this is text replacement, with parentheses. So what happens here is that if we have that I1 and I2 and we pass it into our multiplication, we'd expect, oh, we're passing 3 and 3. But what you're really passing in is 2 plus 1 times 3, which gives you an output of 5, which is not what you wanted. If you go and you add the parentheses back in, now you get what you expect. So function-like macros, they allow you to perform more complicated preprocessor operations, which we'll see in a little bit. So it allows you to kind of have multiple layers that you can build on to generate one of these constant expressions. And they can also be very useful for generating blocks of code, which we'll also see in a little bit. For C, one cool thing that they've added in C is the ability to create kind of like a giant switch statement using _generic. And for C++ alternative, we've got const expr functions, we've got templates, things like that. So for code generation. So this was a good talk. John Kelb gave it, I think at a meetup somewhere, about how to make a enum struct that has all of the operators that you would expect for a bit field operation. And basically it involves, like, you create your struct, you have your an overloaded function that you can use, and then you have all these using where you define all of the different operators and how they work, and you can do that using templated functions. But every single time you add a new enum struct that you want to enable for all of these bit fields, you're going to have to stamp out all of this code. Well, that's a perfect use of macros. So now, if I have multiple enum structs that I want to make bit fields, I can make this make CPP mask enum, and I can pass in whichever enumeration that I want to enable this for, and it'll just stamp out the code for every single one of those cases for those individual enumerations. So variadic function-like macros. You can actually have variadic macros as well. So this Basically, it's going to be the exact same as a regular macro, except it's going to follow with a ... Now, you would access those values and functions through the _var_args preprocessor identifier. So this is not, you don't have direct access to those arguments. All you can essentially do is forward it into those VA lists. You can't individually name them. So there's an interesting way to handle 0 arguments in a second, but it requires that you have a named argument before the ... And then again, to manipulate those, you can see that those var, va start, va copy, and va end are used in code to actually manipulate those values. So what if you pass 0 variadic arguments? Let's say I have a debug that's a format string, and the way I have it set there, I have a format, and then I have my va args. But at some point, I don't have anything, I just want to print out a debug string. Well, what ends up happening after the preprocessor replaces it is it has that trailing comma there because you have no arguments after it, but it still is going to paste in that comma. So there is a way to get past that. So GCC, if you ever see the double pound sign before VA args, there's an extension that will actually say, if there are no VA args, then don't put the comma in there. Just ignore that portion of it. And then C++20, you actually get this _va opt, which will optionally omit any text that is inside of it after the fact. And actually, it was supposed to be, you're supposed to include everything around it, not just the comma. So that's a typo there. But yeah, it'll include everything inside that VA op if there are no VA args. And then either of those options will make it perform how it should. Now, I could not find any reference in the C2X working paper on whether or not they're going to support this. But I tried it out on a few compilers, and it seems that the C compilers support the VA opt. So use at your own risk. So variadic function macros perform more complicated preprocessor, and you can use it to absorb. Like if you just want to stub something out and you don't care about all the arguments and you just want to absorb everything and do nothing, you can use the ... to just stub things out. C alternative, variadic functions with std args. So you can have a separate function or use the generics. Can't use generics. I'm wrong about that. Or use variadic templates in C++, which is really what this is trying to do. So some things you may see when working with C code. I do it on time here. Yeah, about halfway. Cool. Inheritance in C. So C does not have inheritance, but kind of like I was talking before, when you don't want to conditionally include or exclude things from a struct, you want to use the struct that is what you want. You could do something like this, where we have a common base class, which is introduced by a macro, and then all of our different structs are going to have the common macro at the beginning there. And when this preprocessor comes in and replaces it, it's going to stamp those things out. Now what that's going to allow you to do is if you cast back and forth between these different base classes and points and stuff, because the memory layout is consistent, you can kind of treat it as if it is an inheritance hierarchy, even though it really isn't. But it'll work out that way. Overloading in C. So this is the _generic. Now this does not compile in any C++ compiler I have tried. It doesn't understand what generic is, but what this essentially is kind of a switch statement based on what's passed into X there. And it's going to evaluate the value that is, or the expression that is inside that X, and based on the resulting type of that, it's going to go through and select the appropriate function to replace. So how does this work? So down on the bottom there, we've got our X and Y and our absolute value there. So first thing it's going to do is it's going to go through and it's going to replace that absolute value call with this generic, and it's going to pass in X times Y. And it's going to evaluate, but it's not going to have a side effect. So if you do have like a ++ X or a ++ Y or any side effects from there, it evaluates the result, but it does not produce any side effects. And then it's going to say the result of this would be a double, and now we're going to select fabs, and now it's going to replace the code with that. I've seen this many times in old like embedded code and things like that, where you have a do while around these debug print statements. And I always wondered why that exists. The reason it exists is for this. If we have an if statement followed by our debug, no braces around or curly braces around the if, and then an else, and then another one, if we don't have that loop there and just have our print statements like that, we end up with code like this, which essentially makes that else invalid code because it's not associated with any if. But what if we were to just add the curly braces around it, right? Well, now we've got a dangling semicolon. Again, the else is not valid code. So what the do while does is it allows valid code to be pasted in there, and it does exactly what you expect it to do. This is a big list of predefined preprocessor identifiers. Feel free to peruse them at your leisure. But the two we're going to focus on here are the file and line, if you can see those, but we'll zoom in here. So file and line info. So the line is the current line number in this translation unit that you're working on. And this is where the line macro is used. So if you're using it as kind of like a default argument in C++, it is going to be the line where that default argument is declared. It is not going to be the line from where that function is called. And then file is going to be the name of the current translation unit that you're working in. And then again, the line is going to be incremented for every line, including blank lines, and it excludes lines via include directives. There's also this double underscore func. It is not a macro. It's a kind of a hidden constant character array that's local to each function. So that is actually handled by your compiler. So file and line info, pretty straightforward here. So we've got our file and line. It's going to print out main c.4. But there's an extra thing you can do with this file and line info. There is a hashtag or a #line directive that you can use to actually manipulate the line number and file name that you're working with here. So the line number has to evaluate to a sequence of digits, and it'll be for the following line after this line directive. And the file name itself is optional. If you don't specify it, it's just going to use whatever the current file is, but it does have to be a quoted string. So that allows you to do something like this. Please don't do this. But you can, if for some reason you need to, manipulate things this way. And if you see someone, at least now you know what's going on. So file line info, if you have C++20, you can use source location. So source location, if you do source location current as like a default argument to a function, that actually is going to grab the current call site line, not the line where it's defined. So it's a little bit more useful for doing call site diagnostics. But the equivalent for that is, so a double underscore line is equivalent to the line member, and the file is equivalent to the file name member. And there's a few other things that you get with source location that you don't get with these predefined preprocessor directives. If you don't have C++20, there's really no alternative. And again, if you're using C, there's no alternative to this as well. These are just diagnostic information. Stringification. So, stringification. What is the output? Has anybody seen stringification before? What's going to be printed here? Yes. So what stringification does is it takes an identifier to introduce what you're going to do. This is going to be kind of like a function like, it's going to be the identifier of the function like macro. And it's going to take a text to turn into a string. So this can be any text, but it can't interfere with translation units 1 through 3. So the text that you put after it can't manipulate the character system. So a good example is if the text contains like a less than or a sign, that kind of messes with the first phases before it. Same thing with backslashes in it. So those types of things will mess with the previous phases. So some things won't compile. And then the text is going to auto-surround with quotes. So yes, like you were saying there, it's going to, whatever you put in there, it's treating it as text and surrounding it as quotes. So it is not passing in a value. So if you do want to have quotes, you can escape them with quote /quote to escape and actually get quotes in your output. So here's that stringify 45. After the preprocessor evaluates, it's going to output 44. But what about something like this? So if we have the stringify value, what is this going to output? Value, right. So it's going to output value because it's just taking what was in value and turning it into a string. So, as with all programming, we need another level of indirection. Now we've got a stringify and a stringify impl. So the way it's going to work is it's going to kind of do a first pass to sub in your 44, and then I'll do a second pass to output the 44, to actually evaluate the preprocessor directive. Concatenation. So if you have £1 it's a stringification. If you have double $ not followed by VARGs, it is concatenation. So you can do weird things with this, like create a variable using the preprocessor. So here we don't have any myVariable defined, like as you're looking at the code, but we're returning myvar, and this stuff compiles because what ends up happening is we introduce the identifier, and then we have these two sections of text, and we smush them together as text, right? So this can be any text, but again, can't interfere with those translation units, and it's going to concatenate those literal values together. And again, as with the stringification, if you do want the literal, the replaced values, the macro evaluated values concatenated, then you do need that other level of indirection. So for that myvar, what the concat does is it takes those two strings, puts them together, and now there is actually where our variable is declared. And here's our double level of indirection. So we've got our submodule that we're in, the function that we want to append to it, and we've got our double level of indirection. So the first thing it's going to do is it's going to replace with those two strings. Then it's going to replace with the actual string, and that was a very convoluted way to call a function. So when to use double pound and pound. If you need to generate function or variable names, so if in code you need to kind of generate and stamp out classes or functions or things like that based on, basically it replaces a lot of boilerplate code. In C, there's really no alternative to do this. So if you've got like a long table of things or there's a lot of boilerplate to set something up, a lot of times it's common to see these stringification and concatenation processor directives to generate this code. In C++, consider using templates. See if you can possibly replace that with a templated function or something that's going to allow you to be a little bit more generic. In the future, we're going to have meta classes. And I've also been informed that it's called static reflection and static generation as well. But that's something in the future. There's a link to Herb's talk when he talked about it. No, that's the blog post is what that is. But he did do a talk on it as well. All right, Pragmas. This is where you start getting into to weird situations that are compiler specific. So what I'm going to do is I'm going to kind of go over some common ones that you may see, but this is by no means an exhaustive list of all the Pragmas that you can see out there. So include guards. We saw it before using the conditionals. You've got your if-def, your define, your end-if. There is a Pragma once. And by default, MSVC actually puts this at the top of their header files. And essentially what this does is it's going to utilize the file's location as an identifier. It's going to have some way to determine where this file is in your build hierarchy and things like that. And it's going to kind of use that hash or whatever to say, oh, have I included this file already? Okay, yeah, I have, then I'm not going to deal with it anymore. But this can be tricked. So if you have the file in multiple locations, through your include hierarchy, it's possible that it could mistake the same file twice, like based on symlinks or something like that. So it's still a better idea, I think, to do, and more portable to do the traditional include guards. But Pragma once, you will see that a decent amount of time. The preprocessor stack, I thought this was pretty interesting, so that's why I kind of included this here. So what this is doing is basically saying, I'm going to define something, I'm going to define a value for it, and then I'm going to push whatever x is onto the preprocessor stack. And then I'm going to undefine it and say, as far as the current preprocessor is going, forget about x. X doesn't exist. And now I'm going to define it again and make it -1. And then I'm going to use a conditional check and say, hey, if it's less than 0, then I'm going to define that as true. and then I'm going to come back out, and it's going to pop x. So it's going to say, well, whatever x was previously that I put on there, replace x with whatever I had it there. So I don't actually have to do the undef or anything like that. The pop actually handles redefining x with what I just popped on there. And then now I'm going to do the check for x greater than 0, set posx to true, and what you end up getting is that. So you can actually manipulate how macros are being interpreted by pushing and popping things onto the stack. I didn't state this here, but if it doesn't find the macro on the stack, it just ignores it. So warning and error manipulation. A lot of times you will do stuff in code that you know will generate an error, or it generates a noise error on certain compilers and things like that. So you will see from time to time direct error manipulation in your code as well. So for GCC and Clang, it's got one syntax. So that syntax is going to be your Pragma and then your compiler, either GCC or Clang, and then diagnostic, and then one of these actions. So push is going to push the current diagnostics for later retrieval. Pop is going to replace the current diagnostics with whatever you previously pushed. Ignore is a way to just say, hey, ignore this compiler flag. I don't care about this uninitialized variable flag or whatever. Warning is going to override the compiler and say, hey, now I want to treat this as a warning, and then error is going to treat it as an error. And then your flag is going to be omitted if you're using the push and pop, and it's going to be a quoting string matching the compiler flag that you're trying to manipulate, like a dash W sign compare or something like that, or W uninitialized. For MSVC, a little bit different. MSVC has multiple warning levels that you can introduce. So it's got 1, 2, 3, 4, 4 being the most pedantic, 1 being the most permissive. So that's going to change your current warning level for the section of code you're working with. By default, it's going to set whatever the default behavior was, whatever you had it set to by the compiler itself. Disable is going to actually disable a particular warning number. So MSVC has the different warning numbers that you can enable and disable. Error treats as an error. Once is kind of cool in that it'll only disable it for the following line. So you say, I know this next line has something on it that isn't going to generate a warning. Just disable it for this, but I want this warning everywhere else. Suppress, again, is going to disable everything. Suppress is going to disable next line. And then previous action for warning number. Oh, it disables the previous action, yeah. The MSVC warning numbers, link there. And then the level, that's going to be an optional, so when you're doing the Pragma warning push and the Pragma warning pop, so you'll be able to say, push this level up, or push the current level up and then change to this level, and then pop is going to restore whatever level. So for a particular file, you want to make it so that the file is evaluated as warning level 4, but everything else is warning level 3. You can do a push, do 4, and then do a pop, and it'll restore everything to 3 at a later point. So here's an example where you would use it in MSVC. So here I've got a macro that's defined somewhere else, and you can get this conditional expression as a constant warning. I know it's a warning, I can't change it, so I can put that Pragma warning suppress in there, and you won't get that warning anymore. Linker control. I was very surprised the first time I had to start debugging this. We're having some linker issues, and I was looking at the list of libraries that we were including in the MSVC, and I could not find any of these anywhere, and it turned out they were included via this Pragma comment. And this allows you to manipulate, for MSVC, allows you to manipulate the linker, and if you're doing ELF linker control, or if you're doing ELF compilation, Clang allows this syntax as well. So your type, if you have it a compiler, it just adds the compiler version to the object file. It doesn't really do anything. If you have the lib, this actually adds a library to the search path when linking. So it's going to take a look at the files that you're trying to link, and if it can't find it, this actually now adds an additional file via code to say, hey, there's this additional file that you might want to check for linking against. You can also change the linker arguments for this particular file as well by passing linker command line arguments to this Pragma comment. And then the value is going to be based on what you're doing. So if you're doing a compiler, the value actually causes an error. If you're doing a lib, the path to the library, and the linker, the command you actually want to pass to the linker. So here's some examples of where you would do it. So if you're using Win64, you want to add mylib. If you're using Linux and Clang, then you can add mylib.a. Struct packing. This happens a lot, especially when you're serializing code. So what this does is it basically takes all of the alignment and it just smooshes everything together. Now this could result in like misaligned access to code and stuff like that, but it's really useful if you're serializing things because you want to be able to just have all of the bits lined up exactly. And it also kind of compresses them too, so you, especially in small devices like watches, it doesn't take up that much space. So if you have a Pragma pack, it's going to change the alignment to n bytes. If you have a push and n, it's going to push the current alignment, and then it's also going to set the alignment to n, and then pop is going to restore whatever was previously pushed. MSVC has an extension to this. This extension allows you to associate an ID with what you're pushing. So you can actually push and pop and be a little bit more complicated as to what you want to push and pop. So it's going to associate an ID with your current push or the current alignment. And then when you go to pop it, it's going to pop everything up until that ID. So you can do multiple pushes, multiple pushes, multiple pushes, and then pop, and it goes all the way up the stack. But the weird thing about it is that if it doesn't find the ID in the stack, it actually doesn't do anything. So you would think it would just pop all the way to the top, but it doesn't. It just doesn't do anything. Word of warning about struct packing, because I've run into some very weird and subtle bugs about struct packing. Struct packing lasts until the end of the current translation unit. So if you have a header included after you define a struct pack or from another header that you include, and you don't restore the proper packing, it's going to propagate through all of the code that's pasted in below it. And that can result in some very subtle and weird bugs to track down. So be very careful when you're struct packing to make sure that you clean up after yourself. It should be used for serialization, extreme memory constraints, and it can mess with optimization, cause unaligned access, cause extra instructions to be, there's a lot of things that go on, so be careful when you're doing this. And another thing to keep in mind too is that even if you use default alignment for a struct, or class or whatever, and that includes another struct that has a pack, that actually affects the alignment of the struct that includes that struct as a member. So something to keep in mind as well. Remember the beginning when we had a preprocessor directive and I said you cannot introduce another directive either via a pound or a macro expansion? It wasn't entirely accurate. There's the underscore pragma that was introduced. And what that does is essentially evaluates the string as a pragma. So here we have something, if we want to pack our struct, we can say pack level is underscore pragma pack push. So now we're actually defining a pragma in another object like macro. Otherwise we're doing nothing. And basically what that ends up being is it replaces that pack level with our pragma pack push. So pragma and pragma, limit the use as much as possible. It's non-portable in a sense that it works specifically on certain versions and different compilers, so it's not going to necessarily work across them. It also just kind of confuses the entire build system if someone's trying to reason about how your code is being compiled and how things are working. So, because it's going to subtly change in the code itself, not in the build system. For C, there's attributes. So your compiler does have these like double underscore attributes and declspec. These are going to be a little bit more specific, but again, not very portable. And then for C++, same as C. So, quote I would like to leave you with is, I'd like to see the C preprocessor abolished. However, the only realistic and responsible way of doing that is to first make it redundant and then encourage people to use better alternatives and then years later, banish it. So as you can see, there's a lot of progress that we've made and things that we can do to have better, more type-safe, more stable ways to generate code and to manipulate code instead of using the preprocessor. But there are still uses for it, and people are still going to be using it for many years to come. And Bjarni doubled down on it this year too. So it was kind of cool that I saw he's like, yes, I still don't like the preprocessor. So cool. And with that, anybody have any questions? Arthur.
So back near the beginning of the talk, you showed at least to slides that had an if context for and then a macro inside the if context for condition. And you said you can do this, like that's something you can do instead of pound if. But then you showed at least one way that it could kind of go a little bit wrong.
Yes.
What is your actual advice there? Spoiler alert, my advice is don't do that ever.
Yes, don't do that ever. That is, yeah, I mean, if you can, kind of like I was saying in those like sections afterwards, if you can avoid using a macro, if you don't necessarily, I use macro and preprocessor directive interchangeably, so if I say that, that's what I mean. But if you can avoid using a macro, do it. It's gonna make the code clearer, it's gonna make it easier for someone to reason about. Like, if you can avoid doing it, by all means, do not use a macro. But in some situations, it's kind of the only way, like in that if const expr.
So are you saying don't mix if context with preprocessor stuff? If you're going to say pound define value to 1, use it with pound if. If you're saying static context for value equals true, use it with if.
That's not what I was saying, but that is definitely better advice than I was saying. Anybody else? Yeah. Yes, I actually had something set up here. Except it's on that screen and I can't see it. Oh, repeat the question. Can I show what the output would look like? Yes, I can, but it's gonna be weird looking because I am not. Oh. Yeah, look at the dot. Well, so, how to get it? Oh, how to get it? There's a -w or /w for MSVC and a -E for GCC and Clang that will spit out that data. And then if you go to Godbolt and you do the -E, it'll actually spit out the I file, and you'll be able to see how all the preprocessor is manipulated.
You mentioned how with Pragma pack you need to be careful because files included later will also inherit that. Is there a way to disable that after the section of code where it's needed?
So is there a way to, if you have the Pragma pack and you don't, and you include stuff after it, how do you disable it? So you do the Pragma pop. So you do the Pragma push 1 that'll push on the 1-bit alignment. You define your struct, and then immediately after it you do Pragma pack pop. And it's going to restore it. And in some code, people have like a section of structs, and they do the push, have all of their structs, and then do the pop at the bottom. But under maintenance, that runs into some issues. So it's a good idea just to do push and pop after every single struct, just to make sure that they stay together. Yeah, question from online?
Yes, a few questions from online. So first question is, when might you want to use Pragma comment to control linkage instead of leveraging the build system?
In most cases, I would say use the build system. The build system is kind of the canonical place where you should be manipulating that. I've seen it in instances in like MSVC code where it conditionally includes, because for some reason in some older MFC code, like in the project, you needed to exclude a bunch of default libraries. They even have a setting for like exclude default libraries. And I've seen some code that uses old Win32 stuff that just excludes everything and then includes it. I wouldn't recommend doing that. I would say the 99.99% of the time, use your build system.
Okay, one more question. Instead of if defined thing $thing, can't you just do if thing, since an undefined symbol evaluates to 0 as well?
I would not recommend it because we've actually run into some pretty costly bugs due to that type of thing. Like somebody added some new code, forgot to define a symbol, and all of a sudden it excluded a bunch of code that we needed, but it was really somebody forgot to include a header that included that definition. So I would really, anytime that you get that warning, a lot of compilers will say like, warning, this symbol is not defined, defaulting to 0. So if you see that, fix it, because it can lead to some pretty bad bugs.
And the last questions from online. would you ever need to wrap stringify placeholders with parentheses? For example, defined str of x.
It generally includes the parentheses in the stringify.
Okay.
Arthur.
Do you happen to know why it's called Pragma comment?
No, and it was weird too, because I was looking through it and it's just like, nope, this is what it does. But yeah, I have no idea why they called it, and that's why it was super confusing the first time I saw it. So if any Microsoft devs, if you know, even online, let me know. Yeah.
I've had a few times where I want to look at the pre-processed output. Is there a good way to integrate that with any given build system? So you don't have to actually type out the compiler invocation yourself. It's like not ergonomic.
Yeah.
Way to do that.
I mean, there is a way, I know in some build systems, to generate that I file and then include it later on. I'm not too knowledgeable about the specifics, but generally it's just kind of the way I've used it is just more of a, oh, this is neat type thing. But I believe you can integrate the I file into a compilation process. Yeah.
Regarding the question about why it's called comment, I know there's like a comment section of the object files.
Yeah, so the comment was, I'll get you in a second. So the comment was, maybe it was called comment because there is a comment section in the object files, and that actually kind of makes sense. Maybe they just hijacked, because there's that comment compiler, which puts the comment in there, so maybe they just hijacked that for, it's a good observation. Yes? No? Okay. Anyone else?
One more question. Can unaligned access fail on Intel/AMD? Or is it just slower?
In general, it's just going to be slower in my experience. I haven't run into it actually failing. It's going to generate extra stuff to do alignment, and I know there's some processors that actually have unaligned access. It's a little bit above the stuff that I work with on a daily basis. So I know it exists, and I know things have optimizations for unaligned access. Anything else? All right, awesome. Thank you, everybody.